Could you bring the people in for me, please? Emmanuel, let them know we're starting. Over there. Let them know we're starting. Thank you. Okay, this session is going to be moderated by Dr. Kwabena Fosu Amankwa. Dr. Richard Demoa had to step out, and so he'll continue his able skills of this morning. We're going to continue discussion on making space sustainable for humanity. We had a really rich conversation, wouldn't you agree, about the policy and legal agenda. Really good overview from Etienne Ofong, who really happy that Africa Space Leadership Institute was founded, first of all. So we begin to have that question and that questioning and that close conversations and happening. We really want to expand the offerings of African Space Leadership Institute. I've been talking to Dr. Val Winsame about supporting them with some of the work I'd like to see happen around futures thinking and futures literacy for the space community. But it's really exciting to see the kind of work they've been doing with the limited resources that we have. And that's what we've been talking about yesterday, isn't it? How do we do what we can do with what we have, as opposed to waiting for people to come and save us? So we're excited to continue our conversation now on the technical matters. And so Dr. Kwabena will continue moderation. We have our three guests. And so the floor is yours.
Thanks, Claire. Can I share my screen?
So the first session for today, we looked at making space sustainable for humanity, and we looked at the policy aspect to it. Now we begin the second session. As Dr. Claire said, we're going to look at the technical matters related to space sustainability for humanity. And to proceed with the discussion, we have Professor Paul Baki, who is he's a professor of physics with the space policy and space strategy at Technical University of Kenya. Then we also have Dr. Patrick Essien, who is a research scientist at the Meteorology and Atmospheric Laboratory, University of Cape Coast. Then we have Dr. Smarty Kesan, who is with Space India. That's the CEO, Space Kids India. They will be joining us online. So I hope they're online.
Yes, indeed.
Yes, so I think I've seen Patrick. Okay, Prof is also here. So, Prof,
yes,
the floor is yours.
I would like to share my screen.
Making space sustainable for humanity from the technical point of view. Smarty, you also welcome.
Thank you very much. I would like to share a very short presentation.
Prof, I think you need to unmute yourself.
I thought I'm unmuted.
Okay, we can hear you now.
Yeah, allow me to share a short presentation here.
Okay, you're welcome to do that.
It's not happening. I also shared the same with Dr. Claire. Can she probably? Share it from that end so that
I think you are a co-host, so you can share the screen straight away from your end.
I'm trying to do so, but it's not happening.
Please, then you can forward to Dr. Claire so that she can share it for you. If you can forward the slides to Dr. Claire.
I already did that. I already did that.
She's checking it. Yes. So, Dr. Essien, I think you can take it from there so that when Proson is through, then he will continue.
Okay, thank you very much. So as usual, I'm Dr. Patrick Essien. Actually, my area of research is space weather. and
Okay.
ionospheric and Earth ionosphere. Okay.
Okay.
Okay, so I'm a lecturer and a research scientist at University of Cape Coast, Department of Physics specifically. Over here, we are doing, currently we are doing meteorology and atmospheric physics. And I have already developed a program on astronomy and space physics. This program, you'll be doing it in master's level, but I've also developed a liberal course on astronomy and space physics for those doing humanities, because in the university, when you are in level 100, that is the first year, you have to do one liberal program. So I thought it's an opportunity for those who are not sciences to also learn about or start the dialogue about space physics and then astronomy. So there's a course like that already on the academic board, which will be commencing next year. Currently, we have astronomy club here, astronomy and space club in the university, where we are working with the University of Leeds. And because we have one dome here too, they are sending us optical telescope, in which next year going, we'll be using it to, educate public on the necessity of space and then other things that we can explore. Okay, so back to the topic, making space sustainable for humanity. Because they've already spoken about the debris and then other things, I would like to speak more, and speakers are also many, so I would like to speak more on the issue of the space weather. So the fact is that before you can explore space, you should be able to understand the space environment and then the consequences in that environment. And we all attest the fact that space environment is not friendly, as we can talk about. And yesterday, we all spoke with one astronaut where she told us about the time she spent in space and some of the challenges that she faced. So one of the challenges in space exploration is the effect of space weather on whatever you are doing. Not long ago, I think in 2022, 3rd February, Elon Musk, with his SpaceX, launched 49 Starlink satellites into orbit, okay, with the aim of expanding its satellite internet project. However, just a day after or a day later, there was a space weather event which triggered a serious geomagnetic storm, and it crashes 40 of these satellites that we are talking about. I happen to be part of the scientists, the space weather scientists who sat on this in Madrid, that was 2022, to speak about the consequences of space weather in the satellites in our heliosphere. So for space project to be sustainable, space weather event is one of the things that we should look at. Because assuming a country spending millions to provide a satellite, and then just one space weather event can crash everything down. So because of this, many space weather centers have been established. In Africa, we have one in South Africa, that is SANSA has a space weather center that gives us the space forecast, what is coming from the sun, okay? And when you go to South America, National Institute of Space Research, of course, where I did my PhD, they have a space weather center that has been existed for even more than 10 years. I happened to work at the Space Weather Center for 4 years throughout my PhD. When you go to NASA, they have their Space Weather Center. ESA, they have their Space Weather Center to monitor what is out there and what is coming from the sun. Apart from the fact that the space weather can damage the satellite in the outer space, it is also, a very critical for the astronauts, okay, because these are the high energetic particles that are streamed from the sun into the solar wind, and it's very critical if you have people out there, conducting some certain experiment. Also, when you come to our atmosphere, during space weather, there's a geomagnetic storm. And what geomagnetic storm does is that it hits the Earth atmosphere, which increases the density, especially the ionosphere. And when ionospheric density increases, it causes what? A great drag in the low Earth orbit satellite. And this can cause a lot of signal delays. We can also, when you talk about space weather, you can also talk about its effects on the navigation systems. That is the GPS, the GLONASS, the Galileo, and then the Barbie, depending upon the operator. So, for example, when it comes to Africa Space Agency has a section called GPO, Joint Program Operation, or something of that sort, that are producing or working on navigation satellite. Okay, Sat-Navi or so, yeah. So in the near future, Africa can also has its own navigation systems. Assuming if you don't have any space weather information, and then we launch the satellite, like Elon Musk launched it on 3rd February, and by 9th February, about 40 among the 49 satellites are crashed. It means all the money we put into the work and then effort has been gambled, and we cannot do anything. So space weather is a key and a very critical aspect when it comes to the space sustainability and then space exploration. For that matter, I would like to share my screen and then show just I want to show just a slide, okay, to the people about what the space weather I'm talking about is. I hope you can see my screen.
Yes.
Okay. So the space weather, normally it is being caused by coronal mass ejection, what we call CME, or solar flare, or any other activities that happens on the sun. And this eject particles into the what we call solar wind. And this solar wind are being moved away from the sun into the interplanetary medium. When it gets to the Earth, on Earth there is something called magnetosphere, which is the magnetic field around the Earth. What happens is that if it happens that the polarity of the solar wind and that of the magnetic field are not the same, like like poles, repels, and unlike poles attract. Okay, so when they are unlike, they connect. And when they connect, it passes through the magnetic field lines, giving us the light called aurora. Okay, and if they are like the poles are like, it compresses, okay, creating a high impression, okay, on the Earth. And mostly ionosphere, Earth ionosphere, which is very critical to the signal, the communication signal, the navigation signal, and then all the internet signal or whatever, is highly affected, okay, it's compressed, and then it becomes highly ionized, and then increase in its density. So this tend to cause a lot of problems to our system on Earth. So for space, I'll conclude that for space, exploration to be sustainable, or making space exploration sustainable, the issue of space weather, among others, like debris and then other things, should be highly looked at, so that by the end of the day, we will not run at lost. I think there are many to say, but we have other speakers to around, so I'll pause here and allow other speakers to make their submission. Thank you.
Thank you very much, Dr. Essien. Right. So we go back to Prof. Prof, are you there?
Yes, I'm there.
Yes. So Prof, you can speak to your presentation without sharing, if it's okay with you, because you haven't some technical challenge at hand.
But there is another one still on the screen. Eh?
Yeah. So Patrick, please stop sharing so that Prof can come in.
Okay, just give me a minute.
Okay, so Prof is on. Prof, please, you can go ahead.
Thank you. Let me try to enlarge the screen. Thank you very much. Mine will be very short. I think a bit of it has been touched on by Patrick. And what I want to talk about is okay, I can see it's David sharing it. David, then can you enlarge the screen?
The technical people, can it be enlarged mine?
Pardon?
Yeah, Prof, it is you can enlarge. If you put it on slide mode.
Slide mode.
If you go up, that's the extreme right side of your screen.
Yes, I can see. Okay.
Yeah. It's clear now.
Thank you. Yes. I need to be able to move it though.
When you finish this, I can click on the right arrow. It will go to the next slide. We are seeing it, but you may not see it that way at your end.
Okay. Oh. I don't know what's going on, but anyway,
yeah, you can proceed. You can proceed. If you don't even see the slides, it's okay. You can read them here.
Okay, good.
Sorry to come in. Maybe if you guys can take me.
So Smarty,
I just have
Smarty, I think you can come in now that Prof is having some technical issues.
Yes, Professor, by the time he is able to work on that, because I do not have anything to, run through. It's just that I'm going to be speaking. Okay. So, hi, everybody. Good morning. And this part of the world, it's evening. I am Dr. Srimati Kesan from India. I run this organization called Space Kids India, an aerospace organization. And we've started this, I should say, about a decade plus. Initially, when we started, I was taking children to NASA, ESA, and GCTC. And this was more like a scientific exploration there at these research centers, because that was the, gap in India. And there was a huge gap for space programs. So that is when pioneered this program and started this. After that, digging deep and diving deep into the space industry, got to understand how satellites are being launched and, the sustainability towards launching satellites and not creating debris. Everything was, in detail we were going through. And praise of God, 2015, we launched our first high altitude balloon. This was the first ever in the country. There was no prelude. And, it was fantastic that we were able to do this with children. Children in the sense 8th grade until, 11th grade. 14 years until 16 years, children, we were able to do this. And there was no looking back. From there on, we moved and we've launched about 19 balloon sats and 3 suborbital launches and 4 orbital launches. Well, my previous speakers were talking about space debris and how we need to look at space as a sustainable place. And there's so much of debris being created. Of course, I do agree with all that. But if we have to do research, if we have to know more about Earth, then space travel is the best. I think, Dr. Merlin, I think previously quoted that maybe we need to have a system where each country is allocated a number of satellites that can be launched in a year. Because what happens is one country is got a leeway to launch at least 400 to 500 satellites in a year, whereas the rest of the world, when they have to launch 2 satellites, 3 satellites, there's a huge sanction, embargo, so many things come into vogue. So that, I think there needs to be a committee that is able to look into all this and allocate the number of satellites that can be launched in a year. And I think everybody is running towards the moon now because the ecosystem that we have on Earth and, almost like similar to the moon, and that is the closest to people from Earth. And I love the moon. I'm so passionate and I really want to go there once. And I'm going to be taking Dr. Claire there. We're going to be having, I think pretty soon there will be tourism there on the moon too. And saying that, I wish to speak about the satellite that we are embarking on. Mission Shakti Sat, a spacecraft that will be injected into lunar orbit. And this will be built by 108 children, girl children from 108 different countries. We will come together to build this spacecraft, because if you are, going through the list of countries who've launched satellites, of course, their number seems to be high, 80. And there are so many of them who've just had a collaboration, and predominantly it is a 5 or 6 countries that have been repeatedly launching. And I think space is the final frontier and the future, of course. So I thought that probably we should bring in everybody, about 108 countries together, small countries who've still not started on any space programs. We need to bring them all together. Of course, Dr. Claire is our advisor, and we want to bring everybody together. And this is for humanity. This is for peace. And this is going to be for girl power. The recent satellite year last that we had launched for our Indian 75th independent anniversary was the most prestigious one, where we had 750 girl children from humble backgrounds, from Kashmir to Kanyakumari, handpicked, trained them, and we built the spacecraft. Similarly, that's a prelude. So now the actual picture is going to be that we are going to be giving space awareness to almost 12,000 girls across the globe. handpick 108 from them and bring them to India for building this spacecraft. So predominantly, I am looking at having African children with us. So I hope, wish, and pray that the universities and the schools and the organizations from Ghana, from across the length and breadth. Yes, of course, Mr. Lukovi Seke from STI, I think Nepal. He is been supporting us to bring in Mozambique, Lesotho, so many countries. But I think that's not sufficient. We need more and more countries from Africa, the smaller countries, to come join hands with us to build this beautiful spacecraft, to give girls, an entry into STEM as, a profession, look forward to all these girls coming in and joining, and look forward to your support, Space Ungana. And we wish to take you on board as our partner, Space Ungana, and requesting your support. So I think that is what is that I wanted to share from our side. Well, a small treat. This is the first, satellite that we built. This is the Kalam Sat. This is the world's lightest and first ever 3D printed satellite that went up a NASA Stereo Orion from Wallops, Virginia in 2017. So this is called the Kalam Sat. Thank you. And this was built by students from the ages 14 until 18 years. So there is so much of potential among children. It's just that we need to give them the right kind of guidance, navigation platform, and I think they could just fly. So we're all here joining hands and making space as beautiful as possible. From Earth, you see space, it's beautiful. And astronauts from space, they see Earth and they say it's beautiful. So what I wish to say is the entire universe is a beautiful place, and we are blessed to be here on the most precious planet called Earth. Let's save this planet. Let's save space. Let's learn, about space and about Earth, and make this place, make this human race the most beautiful race on Earth. Thank you. Thank you so much for this opportunity.
Thank you, Dr. Asmati. Thank you. But before you leave us, can you share some of the materials that you use to, encourage the elementary student to build their interest in space exploration with us? I can share it with maybe you have an email that you can share it with us.
Yes, I can share our email in the chat box. I can do that. You can write to us. You can write to us, and you can join us in our programs. And more so, I am looking at ambassadors, women ambassadors who can don the role and take their country forward, bringing in girls. I think what I can do is probably tomorrow, I think, again, I'm speaking, I can share the link. I can share the link so that, you can have a look at it and know more about ShaktiSat, and you can write to us and be a part of this historic mission.
All right. Thank you very much, Dr. Asmati. Now we go to Prof.
You. Yeah, thanks
Prof,
again. Yes. Can you hear me?
Yeah, I can hear you, Prof.
Yeah, someone has agreed to share my screen. So next slide. Next slide. Can you enlarge it a bit? But what I want to say is that why do we talk about space sustainability? It is because we want to use the space environment to meet our current needs and also preserve it for the future generations. All this in order to address our current challenges and needs. And while doing this, we need to appreciate that we are talking about an environment. What we need to sustain is an environment. So what does the state space environment consist of? You find in there gravity, you find the atmosphere, you will find vacuum, you will find micrometeoroids and debris. The micrometeoroids actually are some rocks which are floating around. So they too pose danger to infrastructure that we deploy in space. And of course, we have radiation and charged particles. So this is the environment in which we need to do business in a sustainable manner. Next slide. Yeah, so all this is controlled by the sun. Our space environment is largely also controlled by the sun, apart from what we add to it from the human side. A large chunk of what is obtaining there is controlled by what the sun does, which is the sun's activity. I think Patrick already alluded to this, so I'll move on to the next slide. Yeah, so we find all these interactions between the sun and the near-Earth space environment, bringing forth some impacts on technology, which we call space weather. And space weather will impact the infrastructure that we have in space, such as satellites. It will also impact Earth-based systems, technological systems. So it is both ways. Whatever you have in space can be affected. Whatever you have on Earth, too, can be impacted by this space weather. And so as we talk about sustainability, we need to think about these two extremes. Next slide. Yes, this is an illustration of what it does. You can see astronauts in space can be affected by the sun's activity. Of course, we have our satellites there, which can also be damaged by these space weather effects. But when you look down, of course, we have passenger aircrafts, but we also have communication systems which can also be compromised. Even as you have your infrastructure in space, it needs to communicate back down with the ground station. So, but that can be affected too. Similarly, even the power grid on Earth can be affected by what is happening in the space environment above. Next slide. Next slide. Okay. Next slide. Maybe I can just move on to the next ones. Now, certain critical issues must be considered when dealing with space sustainability. We first of all need to understand the risks in the space environment so that we design mitigation measures into the infrastructure that is going to be deployed there, which means that the space environment informs the engineering options which must be put in place when designing, for example, a spacecraft. And it also means that we have to consider pollution that may be caused by rocket fuels, which lead to depletion of the ozone layer, the use of nuclear sources in space, as either fuel or weapons, is also a threat to sustainability. All this means that we have to be hands-on in terms of space situation awareness and also in terms of space weather, because we have to monitor what is happening largely due to the sun. We also have to monitor our own contribution to pollution of the space environment. Only when we have taken into consideration these two can we be able to monitor what is happening and be able to address the concerns arising from the pollution of the space environment. So, why does this matter to us, for example, in Africa? And I think this is going to be my last one. Indeed, Africa has a dream, the dream to do big business, and Africa has put in place an agreement called the Africa Continental Free Trade Area, or Free Trade Agreement, which will bring together 55 countries, and the aim is to enable free flow of goods and services across the continent and boost trading position of Africa in the global market. This agreement is meant to advance trade in value-added production across all sectors of the African economy. The focus will be in 5 priority areas. This is tourism, transport, business services, communication services, financial services, and travel-related services. So now for this to be realized, certain investments must be made. And these investments would be in terms of energy, especially electrical energy, because you will have to move goods across countries. You will have to export electrical power across boundaries. But this is when certain things begin to happen because of what is happening in the space environment. You will have energy disruptions arising from power blackouts, arising from geomagnetically induced currents. Those currents will also impact railway lines because you will have very long electric railway lines. They can also impact oil and gas pipelines. These days, there are so many deposits of oil and gas discovered in various countries in Africa, and I think they are being transported across borders. When that is the case, and you have all these very long oil and gas pipelines, then you have magnetically induced currents flowing in those pipelines, which can degrade the system and potentially cause accidents. Same as optical cable, communication cables, which run through the undersea. All these things can also suffer from the impacts of what is happening in space. I just want to mention that Africa has seen one practical example of space weather when South Africa lost its homemade satellite in 2011 to space weather. Then we saw the real impact that the space environment can do on the infrastructures that we are deploying there, which means that we have to invest in research so that we understand where we are going to put our things and also be able to design mitigation measures so that we take care of any such potential threats. That way, we can say effectively that as we are considering the technical matters involved in sustainability of the space environment, then we have to invest in research in those areas. At the moment, I want to say that we still have very low mass of expertise available in the continent, so we need to build capacity so that we are able to rise to the occasion. And also, even as we do the research and so forth, we need to relate all these researches to what the ordinary person needs to see, that the economy is growing, that we can bring services to the people from the science that we do in all these fields, so that even the policy makers would be able to find a reason to support that research and to be able to take the continent to the next level. I think I want to leave it at that point and maybe take any questions if there are any.
Thank you very much. Thank you, all the panelists. I have this question. I'm trying to look at sustainability in about 4 cases when it comes to launching satellites or space science. Now, I want to look at the building of satellites, then the launching, then operating, then decommissioning. Now, do you think Africa has the capacity to build satellite in terms of the materials that will be required in building it? For example, the aerospace grade aluminum or titanium. We look at the insulators that will be needed, the harnessing power for the satellites, then the other electronic components and batteries that will be required. Do you think Africa now has the capacity to do that?
In my own opinion, yes, we have the capacity to do these things. When you talk about Africa, you are talking about all of us, the 55 countries in the continent. And I want to believe that the reason why the African Space Agency was established was to be able to bring forth that synergy and bring the expertise together so that we are able to pool the resources and be able to do things that we purpose to. Remember that Africa also has a large pool of diaspora who are already in these spaces doing the kind of things that you are talking about. So to me, yes, and Africa has indeed the mineral resources. Some of those things that are being used elsewhere come from here. And it is only when we begin to exploit them for our own use that we will see a tremendous growth in the space sector.
Thank you very much.
That is my take.
Okay. SN, do you have something to add?
Yeah. So I'm very happy you asked this question, and this program is being hosted at All Nations University. You know, we have all the capacity, okay, and everything that can take us to space, produce satellite on our own. But we all have to believe that, you know, we need to have the leadership role, and a lot of money has to also go in, and a lot of sacrifices have to go in. Because 10 years ago, more than 10 years ago, I think All Nations University was able to put even CubeSat, launch CubeSat into space. So assuming if we have all those efforts from the time they launched a satellite up to now, then by this time we have the leadership backing and then everything at their disposal. Like by this time, I think they've been able to produce the bigger one. So we have all the capabilities. Like Prof said, when you talk of Africa, you are talking about a giant like South Africa. South Africa is giant in space. They've launched many satellites into out there. Even Nigeria Sat-1, Nigeria Sat-2, NECOMSAT, Egypt has launched some satellites. And then other countries. We have all the capabilities. We need to sit up and then, you know, do the necessary work that you have to do, invest in research and then satellite production. And I believe we will get there sooner than later.
Okay, thank you very much. I think Smarty has left. But my follow-up question is, if we have the capacity to do all this, now, what is limiting our impact on the continent? What is limiting our impact on the continent?
You mean impact of all these initiatives?
Research on the continent. People are not seeing what the various satellites we have done, we have launched, what they are producing or giving out. All that we know is Starlink.
Yeah, no, let me say here that you put your money where your mouth is. I think South Africa has demonstrated that you can do these things domestically. You can build and launch in space. They have invested money in that. What has not happened in other countries, as much as the technical capabilities are there, is for these countries to invest in it. Until at such a time that we are able to do the manufacturing ourselves, then people will not see the impact. Yes, the capability may be there and the human resource, but until you purpose to invest in it, you will not see the benefits. Probably that is where we are still not doing well. But I think we have demonstrated by building the CubeSats, by building the smaller satellites and launching them into space. And I think that way, what needs to be done is just to be able to work together. Sometimes we do these things in silos, but it doesn't help at all in the long run.
Okay, Prof. So does it mean
Hello.
researchers does it mean researchers need to diversify a way of doing things? Because a musician will release a song in about 2 or 3 days, the whole world have heard about it. But researchers, we do work, and the only thing we do is just to publish in one journal, and that is it. Nobody cares about it again. So does it mean we need to, take a real look about how we advertise or how we let the world know the things we're doing?
No, we have to commercialize the research outputs.
Thank you very much. Yes. Yeah. Anything to add?
Yeah. So concerning what we know only about Starlink and then other things, it seems like I said, we don't try to continue with our research or with our capabilities when especially there's a failure or pause in a way. I want to use India as an example. In 2008, October, they launched Chandrayaan-1 into moon. And there was a problem. Okay, so it's in one way or the other, you say the mission failed. But they worked hard again to launch Chandrayaan-2. Okay, so the thing is, it's not just a day work. Okay, we need to continue. And like I said, we need a leadership role. Okay, we have to invest into research. We need to invest into space production, the satellite production. So it's not just 1 day, it's not just two years, it's not just 3 years. The research has to be continuing. And the issue of publicity, apart from commercializing it, that is why many people too are also talking about STEAM. So it's not only about STEM. We need to bring all on board. The journalists have to have knowledge about space. The lawyers have to have more knowledge about space. Okay, but for example, in Ghana here, when you go to many law schools, they don't even know that there is something called even space law. Okay, yeah, all they know is the constitutional law, the criminal law, and then other things. So we need to bring all on board. Okay, so that the journalists will know what to say to the public. So as we are doing the research, we are producing the satellite and then other things, they will also be doing their part to put this thing before the globe. Okay, for everybody to know that, no, this is what is going on, and this is the way out that we all have to embark. Thank you.
Thank you very much. Now, Ghana is currently known to have lithium reserves. As we try to contribute to world space, can't we pick on just the production of batteries to support satellites launching? What do you think? Because I think Africa needs to do that. If we cannot launch, we should look at picking just a component that you can produce. Because we know South Korea, Taiwan, they produce chip. Just that one alone is supporting a lot of things. So if Africa decides to pick, let's say, one thing just to help in the space science. I believe it could help. What's your take on that?
Okay, thank you very much. So Ghana has lithium, Ghana has gold, Ghana has oil, and then other things. It's up to the government to sit up with these companies to know their CSR, that is corporate social responsibility, and then other things, and then know how we will divert some of these funds into space production, okay, for supporting research and then others. We know GMPC is even supporting sports, okay? So it's equally the lithium companies that have come. Of course, they've not started working. That is gaining benefit because the CSR and then other things is out of the profit you have that you can use to do that job. So it's up to our government. That's why when I was talking about the issue of we succeeding in putting satellite out there or succeeding or sustaining our space project, it depends more on the leadership world. Okay, if the leadership pool is there, we can move forward. I think if you remember 2012, the leaders of Ghana by then President Mills was able to sit with the then Vodafone to convert the astronomical dish at Kuntunsi into satellite dish now. The satellite dish then into astronomical dish that we are using. And that gave birth to Ghana Space Science and Technology Institute. So if we have the leadership wall, everything is going to be possible. Whether lithium, whether gold, and whether thing, it's up to our government to sit up with them that, okay, this is what I want from you. They are going to put it in their corporate social responsibilities. And then, support any research related to space and other related aspects. Thank you.
I just want to jump in here about the government responsibility versus our responsibility, especially in a democratic run government. So GSSTI was here and I heard them very clearly say, number one, a space policy is written, has not yet been approved. There has been absolutely how many of the academics in the space movement have organized themselves into an advocacy group to pressure the Ministry of Education or to pressure the Ministry of Telecommunications. If you're not operating as leaders in your own sphere, you can't say the government has 5,100 things to do besides worrying about these technical things, to be quite honest. So this is the role that the reason why when you create either an engineering institute of Ghana, or if Ghana creates, let's say, a aerospace working group of the engineering institutes, that's one way to do it. Or if you create a Ghana Space Society for the general public, and you might create a Ghana Space Alliance for the technical people like yourself, or Ghana Space Research Consortium, you have to have an ecosystem. So when we talked yesterday about ecosystem development, you have to create an ecosystem to do the various things that have to happen. And you have some of you may be in three parts of the ecosystem: in your technical hat side, in your advocacy hat side, and in your private business side, because that's how you have to roll in order to get stuff done. So I was want to point it out that given that the GSSTI gentleman's Dr. Tando said yesterday, the policy is making way for private sector-led space development, it is up to you to think about from now, wait a minute, if this thing drops in 6 months, am I ready? If it drops in 3 months, have we organized as scientists with your friends who are business people? Because sometimes, honestly, we scientists can't see the business model, right? So get your friends who are the business guys to the table and say, hey, we know how to do this. We know it needs to be done. Government is going to be buying satellites from whomever. The telecom is going to buy satellites. The gold companies need to have a remote system solution. We need to be in the space. Let's try and package a deal that, they can't refuse, looking at long-term interests. Benjamin Loma has up his hand. I think we should hear from Benjamin. He's in the audience. And then Patrick, you don't need to raise your hand because you're on the platform. So just drop your hand. You're going to have to answer questions. But Benjamin Lomo, if you could go ahead and ask your question, please give him room to talk.
Taking some few questions and comments from our audience. Yeah.
So thank you very much. So say that space sustainability is not only about what you are doing in your country. In the international community, there is also the International Telecommunication Union, which is working with it's an arm of the United Nations that also looks to the orbital position and the frequency resources. Okay. Currently, there is no law that forbids a country the number of satellites that they can launch into the NGSOs. There is no law. So a country can have a private entity to say, okay, I want to launch 3 million. There is no law. Nothing forbids that company. But on the geo side, so we have the geo and then the non-geo. The geo side, we have what we call planned and unplanned, okay, orbital resources. The planned orbital resources is every country has been given some level of area and characteristics of a satellite component that they can, in future, if they have the means, launch a satellite there. But that covers only their country. What we're talking here is about launching a continental-wide services, because not every country can launch a satellite. And if we don't come together as Africa and sing our praises, nobody is ready to do that for us. The resources are there. Because we don't come together, we don't sing our praises, we don't work together, other private institutions are taking the lead. Okay, when you look at the United States, it's not maybe the US itself taking the lead. Now, it's the private entities that are doing that. And people keep mentioning SpaceX. Sometimes I think we worry ourselves a lot in talking about space. SpaceX is not the only company. All right. We have institutions like Amazon, Cooper, that is also coming to compete. They have the Chinese have also gotten grants. Chinese institutions have also gotten grants coming to compete with SpaceX. And this is all coming. And we cannot sit like this and be looking at our faces all the time, going to talk shops and just talk. And at the end, nothing happens. But what measures do we have to take in place to keep the market, African market, within ourselves? What resources do we need as Africa to ensure that we put space activities at the forefront for the future? Now, those are things that we have to be doing, and not talking about competitions with others. We are not. But what we want to do is to have the resources to be able to take the market that belongs to us. It is very shameful sometimes for you to be in your continent and get reports that other players are making more money in your continent than service providers in your continent. It's very shameful. And this can never happen anywhere unless in Africa. And I think the moment our leaders get to realize that, and sometimes it's not about ego. We need to put the future for people into perspective when we are planning. And this takes a lot of research. And some of our researchers, when they, like you said, they publish only in one journal and they leave. These days, a lot of people don't read in journal. They read on the social media. So what do we do with that? There is a movement in Tunisia called TUNSA, Tunisia Space Enthusiasts. They are very vocal. And this is something when we met in Ghana, the Ghanaian group, we met in Angola. We had a meeting with the AU, and it's something we decided to also mimic when we come back home, together with the all nations and all the other institutions that are also into space. We need to form maybe a very vocal group on technical issues, economic issues, that will be able to, if government is not willing, we have to push government, because when government gets pressure from the other agencies, they are able to act quickly, like Madam said. So this is what we need to do in order to ensure that Africa also takes its rightful position when it comes to space activities.
Thank you, Mr. Sean. Thank you very much. Okay. Any other question? Yes, please.
Sorry, can you hear me though? I'm Benjamin here.
Yeah, Benjamin.
Very well. Thank you. Thank you for the platform. So I'm Benjamin, Ghanaian by origin, but then I've had the opportunity and the privilege to work on a number of international missions. In terms of resources, I see it from two perspectives. I see it in the short term and also in the long term. Now, in the short term, one thing we need to acknowledge and realize is the fact that we are currently not equipped with the right know-how and the resources to go solo, to go on our own. And this is where partnerships come in. I'll give you a very good example. The European Space Agency, for example, is launching a satellite later this year to study CMEs, the coronal mass ejections, which you mentioned. And data from this study will be available to a number of countries. This is information, for example, which we need to explore to see how these data can benefit us to make decisions as well. So in the short term, I know there is a potential in Africa to do things on our own, but partnerships are crucial. No space agency or no space company solely produces a satellite by itself. There are different companies providing different subsystems, which are all integrated to form one spacecraft. So if we can explore these partnerships, if we can get these companies who are already established to partner with us, to provide data, to teach us, to provide us with the know-how, then I do believe we can go a long way to reach our long-term targets. And once we get the know-how, we can do this development by ourselves. Now, on the topic of space sustainability, there are measures being put in place. For example, the inclusion of very hard mission level requirements on deorbiting. Now, satellite producers are looking to add requirements, for example, on like you should deorbit in 5 years or 10 years after launch. And to do this, you have to ensure and also prove that you have propellant stored on board for this deorbiting, for example. So these are hard level requirements, which we can also include. And on the final note, on that same topic, there is also a number of commercial space debris and collision avoidance services which have been developed to date. Talk of ClearSpace, Astroscale, and the likes. And these are companies which are tasked with removing debris from orbit to help make sure space is habitable and also clean for every other producer of a satellite which would like to deploy a satellite in the future. So there are measures to be taken. It's up to us to be able to make sure that we get these information, utilize them to our benefit, and I believe this is the way we can proceed. Thank you.
Thank you, Benjamin. Okay, Joseph.
Okay, all right. Thank you very much. Talking about the sustainability, my take on the discussion is that you're looking at the African region or continent, most nations, like for instance, Ghana, is more or less looking into building capacity because when it comes to space and satellite, we are looking at it's capital intensive, okay? And so for a country to invest, it takes much money, and there will not be immediate direct benefits. So it's just as our previous just as the is it Paul Baki or who said we have the immediate and the long term. So, and we have a governmental system in such a way that it is very difficult for a particular government to push much money and not see the direct benefit in his term of office. Okay, so we have that challenges also there that we also have to take a look at. So until our political leaders understand things in that level, it will always become difficult unless we have a strong policy, okay, that is guiding us in this trend or direction. Because as it stands now, most African nations are looking at building capacity. That's why most are building CubeSat and all that. And to get the direct benefits or to commercialize most of the activities, we are looking at long-term benefits, long-term, not immediate, but long-term. So that's my take on that. And also, secondly, I want to ask Dr. Oaseas about the talking of the solar cycle effects on systems on Earth, communication and other things, as well as the development of satellite and its launch. What cycle are we in now? Are we in the minimum or nearing the peak? And what are the associated effects that we should pay attention to?
Okay, thank you very much. So we are in solar cycle 25 now, and then we are in the minimum. Okay, I think it started last 2 years. Okay, so let's say we are in the ascending phase. Okay, that is the beginning of the ascending phase. And then in the solar cycle, you know, in every 11 years, it comes to an end. We start another solar cycle. So we are in solar cycle 25, the beginning of the ascending phase. We'll get to the solar maximum somewhere, some few years to come. What happens is that during solar maximum, there are a lot of activities as compared to that of the solar minimum because of I think the numerous of sunspots numbers. But things are changing, you know, because on 11th May, we have one of the biggest solar storms or geomagnetic storms in the decade. Meanwhile, we are in the minimum. So if such solar storm like we were expecting it in somewhere 2015, 2014, whereby we were in solar maximum, but we got it in May 11th. Okay, when you check the system, you see, and most of the the spacecraft was pressured. If you look at Elon Musk's comments, that is how the 11th May storm put a lot of pressure, okay, on the Starlink and then other satellites out there. So actually, for now, we all in research, we all know that during solar maximum, there are a lot of activity compared to minimum, but anything can happen per what happened recently. In continue with that, Dr. Claire was asking about how other research institutions are doing concerning the policy and then other things. Yeah. So for University of Cape Coast, like I said, we are working on the atmospheric research lab and then that of space weather lab and then others. So when we wanted to know much about the policy level of Ghana space and then others, we traveled to Ghana space to sit with the director and had conversation, and he was able to assure us that okay, the policy level has gotten to this stage. So we let him know that okay, well, we put all these structures in place, so we are expecting a collaboration of establishing space weather lab and atmospheric lab in University of Cape Coast. Apart from that, we are in talks with many research institutions, like Michigan University is bringing GPS receivers to us here in Ghana. We are part of Conga. I think Conga is a group of researchers from NASA, ESA, and then all over Space Institute that are putting Earth observation instruments across the low latitude. We are also part of, I think, one Johns Hopkins University that is putting magnetometer across the low latitude and equatorial region. So actually, we are open for collaboration. We have a whole observatory here that observes a troposphere. That is meteorological lab on our campus. We are open for collaboration. If you have any instrument that you think it can help in the space weather and then other atmospheric research that will help sustain our space program, then we are interested. You can get in touch with us in University of Cape Coast Department of Physics, and we are going to work well with you. Thank you.
Thank you very much. Yes, Dr. Jude.
Thank you very much. I think one issue that has come up in terms of the sustainability is space debris. I think the mitigating issues that came up is space debris. And I'm interested to know what constitutes the debris and whether there are globally efforts to remove these debris. What's being done? I just want to know that. Thank you.
Okay. So let me go on.
Dr. Claire is giving some comments on that.
Okay.
I'm not claiming to be an expert on space debris, but I did attend the Saudi Space Debris Conference, which is one of the biggest first attempts to have a global conversation on that. So within the U.S. context, a Saudi context, UAE, there is beginning to be conversation about what are going to be the rules of the game going forward. That's going to be worked out. And one of the reasons why I was selected to be a diverse dozen participant last year, I proposed that there need to be a Space Futures collaboratory where some of these decisions would be done through simulation modeling and analog simulation modeling or digital twin technology. And one of the things I think certainly some of the African universities can begin to do is really think about those students who are very good at modeling and IT and software design really should be thinking about developing a metaverse level of these things we're talking about. Nothing has to be built on the real world until it's first built online. And so some of your universities ought to be very heavily invested in, number one, cybersecurity. That's a big piece of the issue. It also should be invested in AI and metaverse and blockchain technology. So Dr. Moriba Jah, who is not going to be able to join us, but he's one of the leaders in this space environment space. So he kind of popularized the word space environment as in environmental management of space, which was not on the table for many years. Nobody wanted to talk about the fact that we're living in even though space is vast, our ability to use it based on what we know today is constrained by what we know about how these radio waves and radio systems work. And so I think that when I go to some of the conferences and expos, we see a lot of companies who have AI-enabled space traffic domain awareness. They have debris awareness. People, the last conference I went to, which is the big satellite conference that happens in March, there were companies from Taiwan, the US, Europe, all kind of pushing their software, AI software, which is tracking the debris first of all, and a few companies that are talking about removal of debris. So there's all kind of technology that's being talked about, magnets, nets. There's a company in Germany that is talking about design for cradle to grave from day one. So no satellite that Africa is thinking about designing now should not have a cradle to grave approach. So this whole opportunity, in other words, the mistakes of the past, we don't expect a CubeSat that's going to be launched today from Africa to actually look exactly like someone else's CubeSat. You really have to think about what new are you bringing to the game. Just to repeat what somebody has already done, that's not very exciting. What is exciting is to say, how can we tweak this to solve one of the new problems that are emerging? And I think that's where the sweet spot lies. We saw that, you can actually 3D print a CubeSat at this point. There's very low cost technology that we use for Max IQ Space, for example, from South Africa. They have sensors that can actually go into Cube. And one of the projects that we were trying to, I think you're actually doing a project that they'll be doing a project later this year, August, where I think the group out of AATI will be putting their payload into another person's CubeSat. So my point is that the first thing that we have to do as the Ghana and let's call it the ECOWAS, since we have Senegal and Cote d'Ivoire in the room, we've got to put in place an ecosystem for the information to be shared just within the ECOWAS system. How are we going to do this? Are we going to have a Ghana Space Society? Are we going to have a Ghana academic space working group? But you have to organize, because otherwise you're going to be talking to no end. So I really want to spend, when we go to the future session this evening and tomorrow on Thursday, those of us who are going to be working on Thursday with road mapping stuff, Dr. Jaja is here to help guide you on how to actually road map your projects. So you're not just talking and leave here, nobody's assigned anything, and we come back next year. Well, I'm not coming back next year to have the same conversation, that's for sure. So what is going to happen when we leave this conversation? That's what you have to be talking about as we wrap up. We have 2 minutes for a
My network.
To the Ministry of Fisheries that we can help your vessels to locate where the potential fishing zones, because in their annual report, they indicated that one of the wastes that they have is the time of searching. The vessels spend a lot of time to search for the potential fishing zones. And of course, they were very interested in it. And it is actually one of the missions of the African Development Satellite Project to offer this data for potential fishing zones. And so I think that the available data that we have, all right, before we'll be able to launch a satellite to space, there is data available. This NASA data, of course, we can offer training to others on how to. It's a whole mass of data from which you can extract so many things, like so many things. But then not everyone is aware of it. So if you want to sensitize your government, you can start showing them this data, and then you can tell them the need why the country needs to have their own satellite.
Please don't also forget to have Copernicus. Copernicus is also there. You can have a lot of data from there. Then you have GPL just for Japan. The India zone is there. So Meteosat and all those ones are there. You can easily access data to support policy decision and direction. So please, researchers, let us do this one. And whenever we do this ones, it will lure people in to support the satellite business or space science. Okay. Yeah, so next session. Thank you all, our panelists, Prof. Baki and Dr. Oaseas. Thank you all for your time. Thank you, audience.